So you've done it. You've made it to the final video lecture for the week. Section 5.6, Solving Polynomial Equations by Factoring. Now, last thing we're going to look at is two applications for polynomial equations. Our first example has to do with geometry, and it's the dimensions of a shed. The rectangular floor of a storage shed has an area of 540 square feet. So as I go through this question, I'm going to mark the things that are important, like this 540 square feet is area. The length of the floor is 7 feet more than its width. And our objective is to find the dimensions of the floor. So we have an area that is 540 square feet. The formula for area of a rectangle is length times width. And we know that the length is 7 feet more than the width. So these are the things that I gather from the question that I've just read. Using this equation, I can substitute it in here, and I can say that the area of this is equal to the length times the width, which I know is 7 more than the length. So this tells me that I have L squared plus 7L. And that's the area. So the area, or 540 square feet, is equal to L times L plus 7. So you can see that this has not been written in general form. So we have L squared plus 7L minus 540. I'm going to go ahead and move that to the other side. And I'm going to set this equal to 0. Now, you might not want to factor negative 540, but a calculator could make this a little quicker. Or there are a few tricks that you can use. I could make this positive 54 times negative 10, which gives me a sum of 44. Now you can see that I'm pretty far off from the 7. But the fact that both of these are even gives me a real chance to do something interesting here. If I multiply the right one by 2, then I have to divide the left one by 2. This set gives me the positive 7 that I'm looking for. So this tells me that L plus 27 times L minus 20 is going to equal 0. So here I get either L is negative 27 or L is positive 20. Since these are dimensions, the negative value doesn't make sense. So we know that the length of the shed is going to be 20 feet. Since the width equals the length plus 7, that's going to be 20 plus 7, which tells us that the width is 27 feet. So we now know that the width is 27 feet and the length is 20. So let's take a look at our final problem. We have a hammer that's dropped from a construction project 400 feet above the ground. The height h in feet of the hammer is modeled by the position equation shown below, where t is the time in seconds. And we're trying to determine how long it takes for the hammer to reach the ground. So if the hammer is on the ground, the height becomes 0. So the first thing that I want to do is set this equation equal to 0. So 0 equals negative 16 t squared plus 400. Now I can tell that a 4 can come out of both of these. So I'm going to say that this is 0, and I'm going to factor out a 4. So I have 4 times negative 4t squared plus 100. Now it's a little bit more clear that I can take that second 4 out as well. And in fact, this time I'm going to take out a negative 4. So I have 0 equals that 4 times a negative 4 times positive t squared minus 25. Now, 0 divided by 4 is going to cancel, so I can just divide both sides by 4 to get rid of that. By that same logic, I can divide both sides by -4, and the resulting equation is t squared minus 25 equals 0. This equation factors as t plus 5 times t minus 5. And that equals 0. So t equals -5, or t equals +5. Since we're talking about time in seconds here, it doesn't really make sense to be 5 seconds in the past. So how long does it take for the hammer to reach the ground? The answer is 5 seconds. So now you've seen two applications of quadratic equations and how they can be used in the real world. Thanks for your attention, and I'll see you guys soon.